dashed lines, they are the goniometer spindles, and the yellow dotted lines are the cryopular nozzles. And at the Zelok ES, it is built around the micro diffractometer MD2, and these two B and C of the diamond light source, they are basically the two goniometers. B is the principal goniometer spindle, and C is the horizontal secondary goniometer. And this at the Swiss light source, this D is showing the spectrophotometer. Coming to the sample positioning. Sample positioning is basically done by the goniometer, which is a central in the oscillation crystallographic method, which is used almost in every MX experiment in which the crystal rotates while recording diffraction images. So initially, during when the synchrotron development is in its initial steps, so there was a problem that usually we need to rotate the crystal at the tip of the goniometer while data collection. But at the initial steps, they face a problem that at the time of data collection, they have to stop that rotation. So now these goniometers have been developed, and while data collection, these are continuously rotating. So the next is complementary spectroscopic techniques. So this step is actually optional, and they have certain applications, like we can identify the kinetic reaction intermediates in structural enzymatology, and we can also monitor the changes in the oxidation states of metal centers. So basically, a end station can be supplemented with a UV or vis absorption spectroscopy, fluorescence, or a Raman spectroscope, based on the type of spectroscopic studies you want to do. And the major drawback of this spectroscopic technique is that it is even more time consuming than the diffraction experiment itself. So to overcome this, some offline laboratories, they perform the pre-spectroscopic studies of the crystal before taking them to the beamlines. So the third one is sample visualization, which can be done by a simple microscope. But now the microscopes are very evolved, and we use on-axis video microscopes, which is drilled objective and has a 45-degree mirror, provide a view of the sample as seen from the source itself. But these the samples, the crystals, what is the problem is that the mother liquor sometimes is opaque, and so these and due to their optical properties, these microscopes may not work. So to overcome this, UV-induced fluorescence microscopes have been invented, which aids automated alignment of crystals within the loops. And the latest one is the X-ray microtomographs, which is used to help locate difficult samples, and also used as a technique for determining the shape and the faces of the crystals. Coming to the detectors, which is now recently explained to you. So the main thing with the detectors is that the area should be large for the detectors. So macromolecular crystallography has been greatly benefited from the development of large area detectors. So initially in the 1980s era, people have used X-ray sensitive films, for which you again require a dark room to generate the films. And later it has been evolutionized, and image plates were in use in the mid 1990s. And now CCD detectors are in function at synchrotrons. The increasing area of the detectors allows data to be collected with improved sign. And the latest one is pixel array data, which is now being used in place of CCDs in certain synchrotrons. So next is sample delivery. So this is a SC3 robotic sample changer, which is developed, which is the outcome of the SPINE, which is a European proteomics project with standard holders and vial. So basically, initially at the start of the crystallization studies in previous initial years, the number of crystals were very less. But with the advancement in the crystallization techniques, the number of the crystals has been increased very much. So there is a need to screen a very large number of crystals at a single visit, which is made essential when a small fraction of crystals diffract very well, and when crystals are unsuitable for a home source, or sometimes we need to permit remote access facilitating research groups to access the beamline. Coming to the sample lifetime, this is very much important for virus crystallographers. So basically, cryocooling the samples, the crystals, it makes the sample transportable and simplifies the automatic mounting of the crystals. Also, cryocooling provides a very large benefit in terms of radiation damage. So we need to cryocool our samples to prevent the radiation damage, and increasing the lifetime of crystals by a factor of nearly 70x. Also, successful cryocooling is near impossible, particularly in case of virus crystallography. So if you will even overcome this, then also there will be certain artifacts in the side chain positions, or with the hidden conformation diversity in case of proteins and other biomolecules. So this is a picture of the Mimi virus crystal, and this is the schematic representation for the cryocoolers, how it works. The last one is the data acquisition and processing. So data acquisition and processing mainly depends on a very key factor, which is the development of control softwares, which allows non-expert users to carry out their crystallographic experiments. A very high level of graphical software layer on the top of the low level beamline control systems are Apex, Tango or Madoka, which have been implemented in the systems like Blue Eyes, MX Cube, GDA5 and BSS in certain synchrotrons. So basically these systems they can perform the functions of sample loading, sample alignment, data collection, and finally analysis of the data collected. So data collection, so initially the two MAD experiments have been done 15 years apart in less than 25 minutes. But now in 1999, a total of 240 images, 3-second exposure per image has been taken for one crystal at 3 different wavelengths, and recently in 2014, nearly 43,000 frames of 0.02 second exposure per frame were taken on 4 different crystals at 4 different wavelengths. And the amount of data generated boosts the need for automated data processing, which should encompass all these three processes, that is preliminary analysis of the raw images, automated phasing and structure solution, which can be done by the following softwares: Elvis, ZIA2, AutoProc, eDNA, Mesh and Collect. So these are some of the automatic steps of the data processing. So finally, to conclude this talk, mainly from photon sources in storage rings to the management of processed data, data can be collected and structures can be determined even for small samples or crystals which may not even be visible by the microscopes. And all these steps are in chain from crystal to structure, and they rely on robust instrumentation and automated control. These synchrotron facilities, they rather than just providing photons and raw data. So initially, at the initial invention of the synchrotron, they are only required for providing photons and raw data. But nowadays, they have been evolutionized to offer a full user experience and ready to interpret data at the end of every lifetime beam time. And with the future breakthrough have to be developed with the advent of 4th generation sources, which push for new instrumentation, sample handling and phasing methods. And these new developments may offer opportunities for scientists to find out different ways to exploit. So finally, to conclude all these, the paper has one sentence, that is, the synergy between instrumentation and science will lead to new insights into the structure and function of macromolecules in the coming years. Thank you.
Yeah, very nice presentation, and fits well to the last presentations I provided here, just summing up the latest advantages. So it's amazing. Questions? questions. Everybody's happy seeing the latest advances. We have one more presentation along. Standard question. Everybody's having the answers. So I have to check with Secretary General after the break why we have this list and only tough people showing up. So then we go for lunch break and meet back in 45 minutes. Okay, so you provide this PPT to Secretary General.
Okay.
We talk about this emulator stuff in the last session. I will just summarize it. Okay, decided.
This will be on 30, 30. Tomorrow all groups are present.
Everyone should be present now before Friday.
I think the better option is
Actually, this is
before leaving lunch, just before lunchtime. It's better if you can instead that this group are presenting. There is no escape also. And the people will also know. Some effort.
Are you ashamed to present to them? Okay, then you subdivide and try to extend it. Extend the presentation and looking at
in all the groups, people are presenting in the group, but in our group, open diagnostics only, each people has one thing to do. Okay, fine. Okay, thank you. हैमबर्ग वाला जो आता है वो मतलब टेम्परेचर वाला तो इजीली लेते होते हैं वो आता है चले कहीं जाने वाले थे अच्छा वो पता चलेगा कि जल्दी के लैब से है क्या रिजेक्शन करेक्ट
That is probably the type of person who made films. Yeah, so that's why